In this question, we've got again a smooth ball and it has a mass of 750 grams. It is falling vertically and is striking an inclined plane at an angle 45 degrees to the horizontal. So we're going to make an inclined plane making an angle 45 degrees with the horizontal. We've got a 750 gram ball that is falling vertically. Before striking the plane, the speed is 5 root 2. So based on what we know, we can resolve this. So the component that is perpendicular to the wall, and then we can also do parallel to the wall. So this is 45, which means the angle up here, that would be 45 as well. And then I get to write the perpendicular component would be 5 root 2 cosine 45, and the parallel component would be 5 root 2 sine 45. Because I know these two, I also know the coefficient of restitution. So the coefficient of restitution is a half, which would then allow me to write, so the parallel component is still the same, 5 root 2 sine 45. The perpendicular component, that would then become a half times 5 root 2 cosine 45. So if we do Pythagoras' theorem, so I've got 5 root 2 sine 45 remains as it is. This one I've got half times 5 root 2 cosine 45, which is the perpendicular component. So to figure out what is the speed after collision, I can do square root of x squared plus y squared, and then that would be my v. So x in this case would be 5 root 2. Sine 45 is 1 over root 2, so we will get 5, and then y is equal to 1 over 2 times 5 root 2. Cos 45 would also be 1 over root 2. So that would also give me half of 5, which would then be 2.5. So I can say my final velocity, or the velocity after collision, would be square root 5 squared plus 2.5 squared. So that should give us 5 squared plus 2.5 squared. That should give us that. And then if I square root my answer, that should give me 5.59. So the velocity, or the speed after collision, that would be 5.59 meters per second up to 3 significant figures. So that's part A. Now for part B of the question, it says we have to find the magnitude of the impulse received by the ball. So impulse always is received or applied perpendicularly to a surface or to an object. So it is very tempting to think of this as, so if we remember impulse from earlier chapters, we know I is equal to m times v minus u. It is very tempting to do 0.75. My v would be 5.59. U would be the initial velocity, which is 5 root 2, and then do this. But please do not do that. That is wrong. The reason is impact, or the impulse, is always considered perpendicular to the surface. So we're going to take this direction as positive for the impulse. That means so I'm going to consider only the perpendicular components while trying to calculate the impulse. So my mass is 0.75. Please remember to change that to to kilograms. My final velocity is, or the final perpendicular component, that would be 2.5. My initial perpendicular component is, so because I'm taking the upwards direction as positive, so the downwards direction would be negative, so that's going to be minus 5 root 2. So I'm going to get 0.75 times 2.5 plus 5 root 2. So 2.5 plus 5 root 2, take that answer times 0.75, and then that should give me 7.17 7.17 Newton meters. So please remember, we are doing perpendicular to the wall when we are doing the impulse. It is very tempting to do this as v minus u and then think about it that way, but please remember it is v minus u.